Yes, hello, hi. Welcome back to EDUHUNT IIT and NEET Foundation classes. This is Sukumar, your chemistry mentor. Nana, in the previous class, I just introduced you mole concept, right? Gurtunda andariki? What is mole? Simply, mole is the unit of amount, right? So now in this class, we are getting into the further application of the mole concept we learned in the previous class. What is that? Simply what is mole? From the previous class, I think you remember what is mole. Mole is the unit for amount. First of all, mole is the unit for amount. Unit for amount of substance. Okay. So simply, if someone asks you, okay, Nana? If someone asks you what is mole, you have to give the answer. Mole is the unit for the amount of substance. Okay. Now, okay. Then what is it actually? Okay, it is the unit, but what is it actually? It is the it is equal to, or we can say 1 mole contains. See, this is the continuation to the previous class, okay? Yes, it is, or 1 mole contains what number of particles? Avogadro number of particles. 6.023 into 10 to the power of 23 particles, I am saying. Particles. Sir, what are those particles, sir? Let me tell you that particles can be atoms, molecules, ions, protons, electrons, neutrons, etc. Pens, pencils, sharpeners, persons, any number of particles. If any particle, that particle can be anything, okay? If there is a 6.023 into 10 to the power of 23 particles of any particles are there, then that number is called 1 mole. Okay, like I explained in the previous class, if you have double this number of particles, if you have number of particles which is double than this number, double of this, then that will be 2 mole. 3 times of this, 3 mole. 4 times of this, 4 mole. Like that. Half of this, half mole. Like this. But the point is, one thing we need to remember here, that is, sir, how this number came, sir? How this number came, sir? Actually, what we did now, we have taken one stable isotope of carbon. Stable isotope of carbon. Sir, we forgot, sir, what is isotope, what is stable isotope of carbon. Let me tell you, I have explained what is isotope and what is isotopic abundance in the previous video also. There is a video with the name why atomic mass is fractional, the video name, okay? Yes, you can watch it. We have taken stable isotope of carbon. First of all, what is isotope? See, if atomic number is 6, I told you already, if atomic number is 6, if the atomic number is 6, then that is definitely carbon, no other atom. Okay, atomic number 6, mass number 12. How it is possible, sir? Yes. Yes, atomic number is 6, mass number 12 means in this 12, 6 is protons because atomic number is the proton number only. So 6 protons, 6 neutrons. Similarly, you have another type of carbon atoms available in the nature, that is atomic number 6, mass number 13, or atomic number 6, mass number 14, like that. That is the radioactive isotope also. Okay, no problem. So these are the different types of carbon atoms available. Okay, there is examples, fine. Now what makes them different? Yes, the neutron number. If you calculate the neutron number at every place, you know neutron number, how to calculate neutron number? How to calculate? Neutron number is equal to mass number minus atomic number. I hope you remember, I explained in the previous class. Yes, number of neutrons here is equal to 12 minus 6, 6 neutrons. Number of neutrons here is equal to 13 minus 6, 7 neutrons. Number of neutrons 14 minus 6, 8 neutrons. Here the number of neutrons is 6, number of neutrons 7, So neutron number is the number which is changing among this atom, but still because of neutron number, because of the change in neutron number, what is changing? Mass is changing. Okay, mass is changing, but still all the 3 atoms belongs to the same element called carbon. Okay, fine. Mass is different. Now these 3 are called isotopes. These 3 are called isotopes. And among these 3 different types, depending upon their stability, they will be available in the nature. And practically it was determined that, or we found that, this is the stable isotope of carbon. That means among these 3, this is the stable one, and this is the radioactive isotope. This is called radioactive isotope. First of all, what is isotope? Atoms with same atomic number, different mass number. Again, shall I tell you? Atoms with same atomic number, different mass number are called isotopes. Among these isotopes, this is the stable one. They found that. Now, what we did? We have taken the stable isotope of carbon. We have taken stable. So, stable isotope of carbon means which one? This one. Okay, do you understand? Yes, I am going to erase this rough part. Okay, yes. Now, we have taken C6H12 as the reference. What, sir? As the reference. And as I explained in the previous video, the name of the video is atomic mass. What you have to do? What is the mass number? Yes, 12. You take the 12. 12 is the atomic weight, right? Just look at the mass number. Mass number is telling you 12. 12 is the atomic weight, and take the value in grams. It will become gram atomic weight. Now, scientists practically determined number of particles in this 12 grams mass. So, the number of particles in this is found to be 6.023 into 10 to the power of 23. Okay, now we have taken this value as the reference. So, we called this as 1 mole. So this is where the number actually came from. Okay, so 1 mole is the, or Avogadro number is the, simply you can say Avogadro number is the number of carbon atoms present in 12 grams of stable carbon isotope or C12 isotope of carbon. Okay, let me write that also for your reference. You can refer it later. Okay, so Avogadro's number is equal to number of carbon atoms in 12 grams of C12 isotope of carbon. Okay, I hope you understand this very well. So whatever this, simply 6.023 into 10 power 23 is the Avogadro number, and if you have that number of any particles, then that number is called 1 mole. Are you getting this? Yes. Now let me take next page. Now little bit get into the application part of this. Now the point is, see, I trained you in the previous video. I trained you how to express the atomic mass, gram atomic mass for different elements, right? Let's continue that further. See, I have taken, let us take nitrogen. Let's take nitrogen. Do you remember the symbol of the element nitrogen? Yes, sir. I remember, yes, sir. And do you memorize the atomic numbers and mass number? And what is the atomic number of nitrogen? 7, sir. What is the mass number? 14, sir. Now what you have to do? By looking at the mass number, 14. 14 is the atomic weight. Now simply take in grams. It will become gram atomic weight. Gram atomic weight. Are you getting or not? Yes. But the gram atomic weight can be called as molar mass. Molar mass. Okay, why, sir? Why? Because in this 14 grams you will find 6.023 into 10 power 23 into 10 power 23 atoms of nitrogen. Are you getting? 6.023 into 10 power 23. So that's why it is called molar mass also, because the mass of 1 mole atoms. Mass of 1 mole atoms will be like that. So like this you can take any element, the concept is same. You can take any element, the concept remains the same. Okay, but you take chlorine, one isotope of chlorine. Chlorine 17, 35.5. Sir, why it is fractional, sir? I made a video on that separately. Okay, yes. Now, so you can see this 35.5. First of all, I'll write the name of the element, chlorine. Chlorine. Name of the element is chlorine. And symbol is Cl. Atomic number 17. Mass number 35.5. So atomic mass comes out to be 35.5 is the atomic weight. If you express in grams, it will become gram atomic weight. Again, gram atomic weight can be called as molar mass. And simply what it means, if you take 35.5 grams of chlorine, if you take 35.5 grams of chlorine, that 35.5 grams contain 1 mole chlorine atoms. 1 mole chlorine atom is how many? Avogadro number 6.023 into 10 power 23 atoms. I will explain you so many examples until you get some clarity along with some confidence. Okay, one more. Let's take magnesium. Okay, magnesium. What is the symbol of magnesium? Mg. Mg is the symbol. Okay, and what is the atomic number of magnesium? 12. Mass number 24. Mass number 24. By looking at the 24, you can say 24 is the atomic weight. Express that in grams, it will become gram atomic weight. It is called gram atomic weight. Okay. Now, gram atomic weight can be called as molar mass. Molar mass. Why? Why? Because in this 24 grams, it is 6.023 into 10 power 23 mg atoms are present, no doubt about it. That's why it is called molar mass. Mass of the 1 mole particles, 1 mole atoms. Are you getting? Are you getting this? Yes. See, you can only understand this only when if you watch the previous video of mole concept. The name of the video is mole concept atomic mass, 7th class. Are you getting? Next, for suppose one more element, like let us take aluminium. See, I told you to by heart learn the names, symbols, atomic numbers, mass numbers of at least 1 to 30 elements. Okay, they must be, you must have those data in your fingertips. Yes, aluminium. The symbol of the aluminium is Al. Atomic number is 13. Mass number is 27. Okay. By looking at the mass number, I can say 27 is the atomic weight. 27, see, mass number, looking at the mass number, 27 is the atomic weight. Okay, fine. You can take it in grams, then it will become gram atomic weight. But that gram atomic weight is otherwise called molar mass. Why it is called molar mass? Because in this 27 grams, there is 1 mole aluminium atoms. 1 mole aluminium atoms. 1 mole means how many atoms, sir? Avogadro number of atoms. Avogadro number means how much, sir? Avogadro number means 6.023 into 10 power 23 atoms. Are you getting? Yes. Okay. Sulfur. Okay. Symbol of the sulfur is S. Atomic number is 16. Mass number is 32. Now, 32 is the atomic weight expressed in grams. Gram atomic weight. This gram atomic weight is otherwise called molar mass. Why, sir? Why? Because in this 32 grams there is 1 mole sulfur atoms. 1 mole sulfur atoms. 1 mole means how many? 6.023 into 10 power 23, which is actually indicated with the symbol, Avogadro number indicated with the symbol N in the subscript small a, like this. Don't write small a. Don't write small a, right? You have to write capital A only. If you write small a, it will look like sodium. The symbol of the sodium element Na, okay? Na is the Avogadro number. Fine. Are you getting some grip in the mole concept? See, I am training you how to express the or how to apply the mole concept to the atoms, the counting the atoms. Okay. So similarly, you can apply the same mole concept for counting any particles. The particles can be atoms, ions, molecules, or any particles. But in our chemistry syllabus, we usually count what? These particles like atoms, ions, molecules, electrons, protons, subatomic particles. Like, fine. Yes. Now, I'll give you a small task. Okay. If I ask you, go to market and bring half mole oxygen atoms. Okay. I asked you to go to market and bring half mole oxygen atoms. Now, half mole means how much? Half mole means how much? You know, 1 mole means 6 into 6.023 into, I am taking 6 into 10 power 23 atoms. Okay. Then half mole means half of that, 6 into 10 power 23 by 2. That means 3 into 10 power 23 atoms. Okay. Okay, I asked you to bring that many atoms. See, point is, imagine it's a funny situation. Okay, imagine there is a shop. And shopkeeper where these oxygen atoms are sold. Okay, fine. Now, how you will ask the shopkeeper about this 3 into 10 power 23 atoms? See, I need half mole oxygen atoms. See, you or your shopkeeper, you can count or not? Can you count them? Can you count the number of particles? Yesterday or in the previous video, I told you, mole is such a big number. You can't count like that. If you keep on counting 1 mole particles, it will take, even if you count 1 particle per second, it will take 10 to the power of 16 years. More than that. Such a big number, we can't count. But the point is, we have a knowledge about this mole concept, na? Yes, what I can do, I know that. First of all, what element you need to take? You need to take oxygen. You need to take oxygen. What is the symbol? O is the symbol. And what is the atomic number? 8 is the atomic number. What is the mass number? 16 is the mass number. I asked you to by heart this. 16 is the mass number. Immediately what you have to take? You have to take 16 is the atomic weight. 16 is the atomic weight, and take that in grams. It will become gram atomic weight. And gram atomic weight is nothing but molar mass, which means in this 16 gram there is 1 mole oxygen atoms. Oh, if you need 1 mole, you have to take 16 grams. But how much you need now? Half mole. That means 8 grams. You or that shopkeeper can't count the particles, but you can measure the mass, na? You can simply ask the shopkeeper, Babu, you pack 8 grams oxygen. Because you know very well, 16 grams contain 1 mole. So if 16 grams contain 1 mole, then definitely 8 gram oxygen contains half mole. So this kind of relation between the mass and the mole is very much important for our mole concept study. Okay, I hope you are getting the confidence and the clarity slowly. Okay, yes. Let me take the next page. Now, there is one big thing I am going to tell you now. What is this? You take any element. Again, which element I should take as an example? Which element? Every time same element of hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, like this, huh? For suppose, I'm take sodium. Atomic number is 11, mass number is 23. Actually, it is fractional value little bit. I am taking 23. Okay, fine. Sodium, symbol is Na. Atomic number, mass number. What is mass number, na? What is mass number? 23. So, 23 is the atomic weight. Express that in grams, it will become gram atomic weight. 23 is the atomic weight, expressed in grams, gram atomic weight. And again the same concept, gram atomic weight, otherwise called molar mass. Gram atomic weight, otherwise called molar mass. Why it is called molar mass? Because in these 23 grams, you can have 1 mole sodium atoms. 1 mole sodium atoms. 1 mole means how many atoms? Avogadro number of atoms. Avogadro number means how many? 6.23 into 10 to the power of 23. Okay, fine. So keep on saying like that. Okay, but you can generalize something here. What? See, I can generalize something here like this. Okay, simply if 23 grams contains 1 mole, I can say like that, na? 23. If you take 23, in the case of sodium, if you take 23 grams sodium, definitely that 23 grams contains 1 mole particles. No need to count. It's already proved, right? So, if you take 23 grams of sodium, definitely that 23 grams is going to contain how many sodium atoms? Avogadro number of sodium atoms, 1 mole sodium atom. So, if 23 grams contain 1 mole atoms, then suppose I have taken W grams. then the W grams contains how many moles? Question mark. It's a simple question. I am asking you, okay? Okay, pause the video and solve it or express it. How to do it? 23 grams. If 23 grams of sodium contains 1 mole atoms, then W grams contains how many? If I say like that, what is this question mark? This question mark will become the number of moles in the W, right? How to calculate this? So how to calculate this question mark? This question mark is equal to W into 1 by 23. Cross multiplication. Simply, it's simple like if 5 pence is equal to 25 rupees. 5 pence, 25 rupees. 1 pen is how much? How to calculate that? 1 into 25 by. It's simple ratio proportion. You are doing by cross multiplication. Okay? So 25 by 5. This into this by this, like that. Now, W into 1, that is equal to W upon 23. I need to write 23 grams here, but generalize this. 23 grams is actually what? 23 grams is gram atomic weight in the case of sodium. So, gram atomic weight. Now, you can generalize this as number of moles of any substance or number of moles of atoms is equal to weight by gram atomic weight of that element. So, if you have any weight of substance given, to find the number of atoms of that element, if you have any weight of, if you have some weight of an element, suppose carbon element, 2 grams of carbon, 9 grams of helium, 5 grams of boron, if you have any element, some weight of any element, then weight by atomic weight, weight in grams by gram atomic weight. So weight by atomic weight gives number of atoms of, moles of number of atoms. Number of moles of that particular atom you are getting. I'll take some example like, let me write a question here. How many, I'll take next page too. How many aluminum atoms are present in 0.9 grams of aluminum element. What I mean by element, ma? Element means group of similar atoms. That means that 0.9 grams, entire 0.9 grams is having aluminum only. No other atom present. Okay, fine. Now pause the video and calculate the number of aluminum atoms in that, and after that check out for the answer. I hope you solved it. Okay. So first of all, how to find the number of aluminum atoms in 0.9 grams of aluminum? Simply it is about a particular element, na? Simply there is a number of moles formula. So number of moles of atoms, I am writing small n, okay? Number of moles of atoms is equal to weight by gram atomic weight. Simply, what is my intention here is weight in grams by gram atomic weight. This weight in grams by gram atomic weight. Some books it can be written like W by AW. So weight by mass by atomic mass. So simply these two has to be taken in same units, because number of moles is just a number, it has no unit. So number of moles of atoms is equal to weight given is 0.9 grams upon Gram atomic weight of aluminum 0.9 grams. Gram atomic weight of aluminum is 27. I know that aluminum symbol is Al. Atomic number is 13. Mass number 27. So 27 grams. So gram cancel. 0. How to calculate this? Get this point to the right side. 9 into 10 power minus 1 upon 27. So 9, 3 9s are 27. It will be 1 by 3 into 10 power minus 1 moles. Okay? 1 by 3 into 10 power minus 1 moles. That's okay, fine. The point is, in the question, we've been asked to find out then how many atoms, not moles. Okay, fine. We know that 1 mole contains Avogadro number. Then n mole contains how many? So simply number of atoms is equal to number of moles into Avogadro number. Please remember this relation forever. Please remember this relation forever. How, sir? Because, listen carefully, we know that 1 mole contains Avogadro number of particles. We know that 1 mole contains Avogadro number of particles. Then n mole contains n into Avogadro number. So that's how you get the number of particles. Now do it. So number of atoms, number of aluminum atoms. Number of aluminum atoms is equal to how many moles? 1 by 3 into 10 power minus 1. That is the number of moles we got into Avogadro number. Avogadro number I am taking 6 into 10 power 23. Okay. Now cancel out. So 3 2s are 10 power minus 1, 10 power 3. So you are getting 2 into 10 power 22 atoms. The answer is 2 into 10 power 22 atoms. That is also still big, such a big number. Are you getting? Let me do one more example for this. How many carbon atoms? How many carbon atoms are present in 0.03 grams of carbon element? So just a question. That means you have taken some amount of carbon. How much of carbon you have taken, ma? You have taken 0.03 grams of carbon. And we've been asked to find out how many carbon atoms are present in this 0.03 grams of carbon. Now let me solve this. How? First of all, how to find the number of particles? Number of moles. How to find the number of moles? Number of moles of carbon is equal to weight of carbon upon gram atomic weight of carbon. Gram atomic weight. Weight by gram atomic weight. First of all, this is the formula. This is the formula with the help of which we are going to calculate the number of moles. Number of moles of atoms. So number of moles of carbon atoms is equal to, what is the weight given? 0.03 upon the gram atomic weight is 12. 0.03 grams upon gram. So gram will be cancelled. Number of moles it is not having any unit. Now what to do? How to do calculation? Get this point to the right side. 10 power minus 1, 10 power minus 2. So 3 into 10 to the power of minus 2 upon 12. 3 1s are, 3 4s are. It will be 1 by 4 into 10 to the power of minus 2 moles. Again, in the question we are not supposed to calculate the number of, we are not supposed to give the answer as a number of moles. We need to find the number of carbon atoms, but simply we know the relation already. How? Number of atoms is equal to number of moles into Avogadro number. Again I am writing this here. Okay, remember this always. So number of atoms number of atoms is equal to number of atoms. Number of moles, how much? 1 by 4 into 10 power minus 2. You can take it as 0.25 into 10 power minus 2 or 2.5 into 10 power minus 3. You can further calculate this as it is 0.25 into 10 power minus 2. So 2.5 into 10 power minus 3 moles. Okay, now fine. Number of moles is 2.5 into 10 power minus 3 into Avogadro number 6 into 10 power 23. So that will be 2.5 into 6 into 10 to the power of minus 3, 10 to the power of 23. It will be 10 to the power of 20. So 2.5. How to calculate this? 2.5, you can write this as 2.5 as 5 by 2. 5 by 2 into 6 into 10 power 20. Okay, na? 2 3s are 6. Okay, 5 3s are 15. 15 into 10 power 20. 1.5 into 10 power 21 particles are present. That many number of particles. See, from the given mass of 0.03 grams, we calculated number of carbon atoms present in this mass. In this just, it's a small zero. In terms of mass, it is a small value. Na? See, 0.03 grams mass is such a small value in terms of mass. But the number of carbon atoms in this 0.03 grams carbon is 1.5 into 10 power 21. Huge number. So that's why I told you in the beginning of the mole concept class, even if you take a small amount of carbon or any small substance, the number of atoms in that substance is a huge number. So that's why to count such a huge number of particles, we need a bigger unit, very huge unit. So that is nothing but Avogadro number, which is equal to 6.023 into 10 power 23. I hope you understand this. Thank you.